Hi, in this video, we will demonstrate the implementation of common pod security policies using Open Policy Agent and Styra DAS. As you may know, as of Kubernetes version 1.21, pod security policies have been deprecated, and they are planned for removal from the project in version 1.25. Open Policy Agent is a common solution for applying security guardrails for Kubernetes clusters, including the types of security and configuration policy rules provided by the deprecated PSP implementation. Styra DAS, or Declarative Authorization Service, is a management control plane for Open Policy Agent instances, and it provides full lifecycle management for OPA policies. DAS also provides an out-of-the-box pod security policy compliance pack, making it fast and easy to migrate from your existing PSP implementation to an OPA-based solution. Let's go through that process today. I have an existing Minikube cluster running on my desktop, which has a PSP called example PSP that has been deployed to that cluster. And I've also deployed a pod to that namespace, which is using that PSP. So this pod is fully compliant with the existing rules in the PSP, successfully running on the cluster. Looking at the YAML behind the PSP configuration as well as the pod, we can see that here. My example PSP, I've configured a number of common settings for pod security policies, such as disallowing the use of privileged containers, preventing privilege escalation for containers, requiring that containers run as node root, preventing access to host level resources like network, IPC, and PID namespaces, ensuring that pod volumes or container volumes are only of a specified type that has been designated in our approved list, etc. I've also created that sample BusyBox deployment to be compliant with these pod security policy rules. So the BusyBox container has a security context configured where it is indicating not to run in privilege road or disallow privilege escalation, to run as a non-mute user, etc. Now, to implement OPA on a Kubernetes cluster, I can do so using Styra DAS, and I will sign into my Styra DAS management control plane instance here and configure Styra DAS to connect to a new Kubernetes cluster. So when setting up a Kubernetes cluster within Styra DAS, I do so by creating a system in Styra DAS based upon the Kubernetes system type. So I'll create a system for my Minikube cluster here. And this will initially direct me to the configuration page and set of instructions where I'm providing the instruction to install the OPA agents into my Kubernetes cluster. We'll go ahead and do that. So running this command will deploy 3 OPA agents out to my Kubernetes cluster, configure those agents as the target of the admission control webhooks for both the mutating and the validating phase of admission control. Styra DAS will also configure those OPA agents to communicate back to Styra DAS for the purpose of management capabilities such as policy distribution, decision log aggregation. We can see that this cluster or this system is already connected, or the OPAs have already connected to this cluster. And so they've been fully installed on the Minikube cluster. And within Styra DAS, we could explore and manage or create and author policy rules for each of the respective validating or mutating phases of mission control. You can both edit and write Rego rules directly within Styra DAS, or choose rules from a pre-built library that contains over 100 pre-built policies for common security and compliance guardrails for your Kubernetes clusters. But with respect to pod security policies, Styra DAS provides a compliance pack for PSPs that we can enable to quickly, again, implement the same type of PSP rules or that are being provided by Kubernetes PSP today. So we can see within the pod security policy compliance pack, we have 19 rules that you can review and configure through the wizard, stepping through each rules to understand the configuration options that might be available to you for each individual rule. You can configure rules in either monitor or enforce mode. The difference between those two modes is monitor provides a dry run capability where the rules will be enabled on the cluster, but they won't actively prevent any workloads that might violate those rules from being deployed, where enforce mode would strictly prevent workloads from being deployed if they were in violation of those rules. We don't need to configure all of the rules through the wizard. We could drop out of the wizard at any time and fall back into Styra DAS's swim lanes view, which now presents holistically the full set of all 19 rules that are present in the pod security policies compliance pack. 6 of those rules are initially configured in monitor mode, while 13 of them, which may require additional configuration, are in the unused column here as well. Again, we can see in comparison to our pod security policies, we have the familiar types of rules, such as preventing containers from running in privileged mode, preventing access to host network, disallowing privilege escalation, enforcing containers that run as root, etc. And then additional rules that require configuration, such as restricting the types of volumes that can be used by pods, we can configure with our configuration settings, such as allowing volumes of type config map and secret, and move that rule into monitor mode or enforce mode as we desire. Generally a good idea when we're first integrating our OPA-based admission control rules with a cluster to initially establish or enable those rules in monitor mode so that we can have that dry run capability and see how those rules behave with respect to the cluster as it's been running already. When I publish those rules out, again, these rules will be deployed now by Styra DAS down to the OPA agents that are running on that cluster. And DAS will immediately begin analyzing that cluster state with respect to those rules. And it will provide the results of that analysis in our compliance view. So the compliance view is showing us what resources already are running on the cluster, which may be in violation of rules or which are in violation of the rules that we have enabled. And so we can see there are 6 violations on the cluster related to replica set pod and deployment configurations around specific rules, such as they were not configured with the appropriate read-only file system attributes set to true, or using unapproved volume types that we haven't yet fully configured in our approved volume type list. In addition to validating these rules through the compliance assessment, the rules will also be evaluated by OPA at the time of admission control. So let's test that functionality as well. I'll jump back over to my Kubernetes deployment. We'll just make a minor change to the BusyBox deployment object here and re-push that out to our cluster to just ensure that this deployment is accepted by the cluster with the new OPA admission control rules in place. We can see that that new pod is successfully running now, and as with the old pod is being spun down. We can also see evidence that that deployment was accepted by the cluster through Styra DAS via the decisions list view. So when the Kubernetes cluster, or when OPA returns the decision to the Kubernetes API server for enforcement, it also returns that or records that decision in Styra DAS. So we can see that decision information has now flowed up to the control plane for our analysis. We can filter and analyze these decisions based on specific criteria. So if I was looking to review specific policy decisions related to the validating phase of admission control, perhaps for resource objects that were created on the cluster, and maybe specifically for kinds of pod, I can do so, filter down and see specifically that there was a recent decision made here, which allowed the BusyBox container to be created on the cluster, even though it violated 2 of the rules that we had set up in monitor mode. The rule for ensuring the container does not have a read-only root file system, as well as ensuring the container use only unapproved volumes or approved volume types. Again, this is to be expected to see the allowed decision because we've intentionally set up our rules in monitor mode at this point in time. But let's change the rule configuration to enforce these rules and see what happens on our cluster as well. Navigating back to the pod security policies file, we can again move these rules into enforcement mode. Now, understanding that putting rules in enforcement mode is potentially a higher impact operation on our cluster, right? We could actually now actively prevent workloads from being accepted or admitted onto the cluster by these rules in enforce mode. We want to kind of test or validate or understand that impact before we actually push these rules out to the cluster. Within Styra DAS, we do so through the validate button here. So when I hit validate, a couple of key things happen. One, if we've authored any Rego unit tests within our policies, those unit tests would execute. At this point in time, I haven't written any unit tests, nor do I need to write unit tests as I'm working just with out-of-the-box policies here. But if you were writing custom policies in Rego, you would certainly be writing custom unit tests and want to reevaluate those frequently within your policy development lifecycle. The second thing that happens in the validate, upon the validate action is an on-demand compliance assessment. So this is effectively, we're showing us the same results that we saw in the compliance view, and we wouldn't expect any changes with our compliance assessment at this point in time, because all we've done is we've moved rules from monitor mode to enforce mode. Again, both monitor and enforce mode rules contribute to the compliance analysis, so changing the state from monitor and enforce shouldn't affect the overall compliance results, and again, we're not seeing that reflected here. We still have the same 8 compliance violations that were present in the compliance view initially within the on-demand assessment here. But what is more interesting in terms of impact analysis is what Styra provides in terms of decision log replay. So as Styra records the decision logs for all the decisions that are made by the OPA instances, it can also use those decision logs and replay them as part of impact analysis for our policy changes. So what we see here is out of 36 decisions in the recent history of the decision log, 7 of those decisions would be changed by the draft changes we've made in our policy, effectively moving those rules from monitor mode to an enforce mode. We can review each of those individual decisions. We can see perhaps specifically for this, create pod decision, which was initially identified as an allowed decision on the cluster in terms of replay, what the specification of that resource was, and why it would result in a deny decision based upon the new policy. For that analysis, we can look at each of the individual policy rules and how they're annotated. So this rule with regard to containers prohibiting privilege mode would still allow this pod to be admitted to the cluster, as the pod specification does include the required privilege mode configuration of setting privilege to false. However, the pod is not compliant with our rule to require read-only file systems within our container. Now, if you're kind of paying close attention, you would recall or notice that I didn't have read-only file system as a configuration in my initial existing example PSP here. So if I wanted my OPA policy rule to be fully compliant with my existing PSP in terms of this migration activity from PSP to OPA, at this point in time, I probably would not set up the read-only file system rule to be enforced, and perhaps not even monitor. Maybe I just want to ignore that for the time being, disable that rule within my cluster until a later point in time. Further expecting the rule list, I can also see that per the draft policy, this pod would be rejected from this cluster in the future based upon the configuration of the volume types, which is perhaps expected because I did not fully configure all of the volume types in my OPA rule as are present in my PSP configuration. So to make my OPA policy configuration fully compatible with my PSP implementation, I'll have to add those additional policy types or volume types such as empty dir and projected volume, the downward API, and then the final one was persistent volume claim. All right, so now this pod volume type restriction implemented in the OPA rule would be fully equivalent to the volume approval list that is implemented in PSP. And we can already see that the annotations within Styra have changed. This rule would no longer result in a denial result of the decision. So the rule would be allowed. And in fact, this the entire decision that was replayed here is now also indicating that this object would be allowed by the cluster. To further validate this, we can run our validation function again to generate a new list of results. We can see now that our on-demand compliance assessment is showing us that all 8 existing compliance violations would be resolved by this draft change. So once we push this change out to the cluster, we're going to resolve all those compliance violations for both the read-only root file system configuration as well as the volume type configuration. And each of our individual rules are indicating that these would be allowed by the policy. And finally, from a decision log replay, we see no changes in the past decisions that were recorded on the cluster versus the new policy changes, right? So we've moved all these rules to monitor and enforce mode, but again, our goal was to just provide full compatibility with our existing PSP implementation in OPA. At this point in time, I can go and publish these rules out to the cluster to enable them and make them active on the cluster through the publish changes function. If you perhaps are wondering, all of the policy are implemented in Rego code within Styra DAS. You can view and manage and edit the Rego code for any rule within the rule library. And we can also fully version control our Rego code in a Git repository. So while I haven't yet configured Git integration for this system, certainly can do so, and then that will persist all of our changes within a Git repository for full and complete version control. Finally, to test this rule out, we'll make sure that our BusyBox container can still be deployed. At this point, this deployment is going to be validated by both the OPA admission control configuration. So the validating phase of admission control will invoke OPA and validate the specification of this deployment against all of our rules, which are now in strict enforcement mode, as well as the existing PSP implementation is still in place on a cluster. So a bit of a belt and suspenders approach here. We have both the PSPs in place and the OPA policy rules in place. But we'll push out that BusyBox deployment, and we can see that has been successfully admitted to the cluster, and those pods are now running or being spun up. To test an alternate deployment, that would show us a violation of those rules in strict enforcement mode, I can quickly try to attempt to deploy another pod that attempts to run in privileged mode here, and I get an error back from the Kubernetes API server, ultimately, or originating from the Open Policy Agent webhook, telling me that this deployment was denied because it is in violation of the enforced rule. So my OPA policies are in place. They're working correctly as expected, fully compatible and compliant with my existing pod security policy or PSP implementation. Good to go to remove or turn off PSPs on this cluster, or at least that individual policy for this cluster, as I've migrated off of PSPs and onto OPA managed by Styra DAS. That concludes the video. Thanks for your time.